Welcome to 1.1b Pure Substances and Mixtures. By the end of this video, you'll be able to write a claim that identifies if a substance is a pure substance or a mixture by analyzing its characteristics and using observations as evidence to support your claim. Video watching expectations. While watching this video, this is the only thing you should have open, and you should be using headphones. Make sure you listen with purpose. Mind your time. Most video lessons should take no more than 10 minutes to complete. Take notes. If you have guided notes, fill in the missing parts. If not, a good rule of thumb is to write down anything in red. Answer the questions that are within the video. And finally, pause and rewind as much as you need to. Your notes will be checked for accuracy. Is air considered to be a pure substance or a mixture? I want you to think of the answer to this question and answer it on your handout. This is a brainstorm question, so I'm looking for effort and just your thoughts in general, and not if you have a correct answer. So pause and answer the question now. So if you're unpausing, you have answered this. And I'm actually not going to answer this question right now. You're going to come back to this question at the end of this video and see if your original thought was correct or if it was wrong and why. So we can classify matter as either a pure substance or a mixture. A pure substance is made up of either a single element or compound, and so it's always homogeneous, which means it always looks the same throughout. Because a pure substance has a fixed composition, meaning what makes it up does not change, it cannot be separated physically. It has to be separated through a chemical reaction. An element is one type of the same atom. So if you're looking at the picture, all of them are the same color, they're all the same type. That's an element because we only have one type. And if you're looking at the periodic table, an element always starts with a capital letter. And if it has a second letter, it's always lowercase. So if you are looking at um, what's it called? Like a chemical structure, like for example, the bottom one says H2O, that has two capital letters. So if you have more than one capital letter, that means you have more than one type of element. And so a compound is two or more types of different atoms that are connected by a bond. So looking at the compound picture, we not only have green, which is one type of element or atom, we also have purple, which is a different color atom or element. And so an example of that, like I said, would be H2O, because H and O are both capitalized, and CH4. And because they're both capitalized, that means the C and H are two different elements or atoms. And elements or atoms are used interchangeably. So element is just the type of atom. So, like I said before, pure substances can't be split apart or separated physically, and elements actually can't be split apart at all because it is down to the most basic type, just one single type of element or atom. But a compound can be split apart. The way to do this is by using a chemical process. So here we have H2O. H2O, because it's a compound, we have more than one type of element, can be split apart into just H and O. And I think the reaction that would like split it apart would be, I think it's called hydrolysis or dehydration synthesis. Either way, it's going to split the H's off of the O so that they're just elements now instead of a compound connected together. So here's example question number 1. I give you 4 different formulas. I want you to go ahead and label the following as either an element or compound. So go ahead and pause here. Oops. Okay. If you're unpausing, that means you have answered these questions. So Fe, because there's one capital letter and the second letter is lowercase, this is one type of atom, which means that this is an element. NaCl, it has two capital letters. Those are two different elements. That makes this a compound. H2O, capital H, capital O, that makes this a compound because we have two different types of elements. And finally, N2. So this one's a little tricky because we have one type of element, but we have the number 2. And so because we have one type of element, one capital letter, that is still going to be an element and not a compound, even though we have more than one N. When you have more than one, um, but they are the same thing, so N and N, that is an element. A compound, they have to be two different elements, like Na and Cl. Okay, cool. Example question number 2. So you have two pictures here. I want you to label which one is a compound and which one's an element, and then underneath explain why. And it's important that you have an explanation so that way when you go back to your notes, you understand why you said it was that choice in the first place. So go ahead and pause here and answer this question now. Okay. So the one on the left is a compound because there are two different types of atoms bonded or connected together. We have a green one and a purple one. They're different colors, which means they're two different things. That makes it a compound. The one on the right side, so we still have two things connected together, but because there's only one type, they're both pink. That makes it an element because there's only one element present. So this would be like an example of like on the last side, like this would be N2. That's what it would look like. So still the same thing, only one type, making it an element. So we talked about pure substances. Now we're going to talk about mixtures. So a mixture is a blend of two or more pure substances, and each of those different substances has its own properties. But when we put it together, the entire mixture can also have its own properties that the pure substances don't have. And mixtures can be separated physically, unlike pure substances. So, some methods to separate mixtures are filtration, using a filter, chromatography, which is a way to separate colors. So, if you're looking at the bottom right of your screen, the one I just circled, that's an example of chromatography. Magnetism, so using a magnet to separate things, dissolving stuff, heating, boiling, evaporation. Those are all ways you can separate mixtures. And so there are two types of mixtures. There are homogeneous mixtures and heterogeneous mixtures. And so the question I have is how do they look throughout? So this is an example of a homogeneous mixture, salt water, and a heterogeneous mixture would be like if we put a bunch of Legos together in a container. And so homogeneous looks the same. Like the salt water looks the same throughout. You can't tell the difference between the salt and the water. And the way to remember that homogeneous looks the same, even though it has different parts to it, is that the beginning of the word homo, that prefix means same. Heterogeneous mixtures, they look different throughout. So, your Lego example, you have a whole bunch of different Legos. You can easily pick out the blue parts, the green parts, the big pieces, the small pieces. It does not look the same. And the beginning of the word heterogeneous has a prefix hetero, and that means different. Okay. So the next question I'm going to ask you is I gave you four mixtures: trail mix, salt water, hot coffee with sugar, and iced coffee with sugar. I want you to label them as either homogeneous mixtures or heterogeneous mixtures. Um, and so there is going to be two of each. So pause here and try that now. Okay, so if you're unpausing, you've answered it and you are ready to check your work. So homogeneous means it looks the same. I am writing with my finger on my mouse pad. So I'm just going to write an S for same for homogeneous. And heterogeneous means different. So I'm just going to write a D. So we know that means different. And so a trail mix, where you have like peanuts, M&Ms, honestly, I'm not sure what else goes in trail mix because I usually just eat the candy. That's going to be heterogeneous because it is looking different throughout. You can pick out each individual piece. And so the next example I'm going to go down is salt water. And so we saw in the previous picture that salt water looks the same throughout. So that's going to be homogeneous, because you can't tell the difference between the salt and the water. Back at the top, hot coffee with sugar. So, because coffee is hot, when you add sugar into it, it dissolves. And when it dissolves, you are not able to determine the difference between hot coffee and the sugar. And it looks the same, which means that hot coffee and sugar is a homogeneous mixture. And lastly, iced coffee with sugar. If you've ever gone to Dunkin' and asked for sugar in your iced coffee, you know that it all just goes at the bottom. So it's super easy to pick out the difference between the sugar and the iced coffee. And because you can pick out that difference, that makes it heterogeneous mixture. Okay. So homogeneous means it looks the same. You can't tell the difference between the different things in it. And heterogeneous means it looks different. You can pick out the different parts of it. And so here's a little flow chart that can help you figure out if it's a pure substance or a mixture. And so when you have a piece of matter, the biggest question or the first question to ask is, can it be separated physically? And so if I have salt water, I know that salt can come out of the water. If you've ever been to the beach and you've gone in the water and dried off, you know that the salt stays on you, but the water doesn't. So, for salt water, it would be yes, it is a mixture. And then the next question I'm going to ask is the composition uniform, which means does it look the same throughout? If I say yes, I know it's homogeneous. If I say no, I know it's heterogeneous because it looks different. In this case, salt water, because it looks the same, I'm going to say homogeneous. So this is just like a tool to use. I think I put it in your notes, so you don't have to copy it down. All right. Example question number 4. You have, I can count 1, 2, 3, 4, 5, 6, 8 different substances. I want you to figure out using that flow chart, if it's, first a mixture or a pure substance, then if it's heterogeneous or homogeneous. So we know homogeneous and heterogeneous, they're both mixtures because they have the word mixture with it. But if you're thinking it's a pure substance, then you need to determine if it's a compound or an element. And that is a very bad looking P for pure substance. Okay. So pause here and sort them now. Each of them, I think, have two answers. Okay. If you're on pausing, you've answered and you're ready to check your work. And I do want to emphasize how important it is to try this yourself first. Even if you make a mistake, you fixing your answers and figuring out why it's wrong is super helpful, and will help you learn much more than just copying down what I have. So, homogeneous, salt water and apple juice, they look the same throughout. You can't tell the different parts of them, so that makes it homogeneous. Fruit salad and juice with ice, you can pick out the different pieces of that, which makes it heterogeneous mixture. So methane, CH4, and carbon dioxide are both compounds. And that is because they are a pure substance. They're made up of one thing, but they have two different types of elements in it, which we know because they have two capital letters. And then finally, your element, nitrogen, which is just N, and helium, which is just He. Because helium has a lowercase e, that means it's part of the same element. Example question number 5, and this is, I will say, is more of a brainstorm question. You pick up a handful of soil from the ground. I want you to figure out a way to separate all the different parts of the soil. And so the first thing you need to think of is it a pure substance or is it a mixture? Because that'll tell you if you can separate it physically and use one of the methods in your notes, or chemically and you have to do a reaction. So I want you to pause here, try and answer this question. So, soil, like if I were to just go outside, pick it, and take a sample of the dirt that's outside, that would be a mixture. There's a bunch of things in the dirt, a bunch of different things. And so, a way to separate the soil means that it has to be a physical method. Okay. So, you could individually with your hands pick out the different pieces. If there's anything magnetic in there, you could use a magnet. You could also use a filter. Some of the other methods that are listed, like distillation and crystallization, wouldn't work for this, um, just because, like, it wouldn't really, um, like, nothing would crystallize. Sorry. So, I'm going to have you go back to your original answer for is air considered a pure substance or a mixture? Instead of rewriting your answer, I want to know in the video, you're just going to type your answer, you're not going to write it down. Did your answer change? If it did, what changed about it and why? If your answer didn't change, explain why you were originally correct. And when you do these explanations, make sure you include vocab words from what you learned today. So, for example, pure substance, mixture, homogeneous, heterogeneous. When you're done, unpause it, put your answer in, and then we're just going to go to the summary. So here's a summary for trying to figure out what type of matter you have. So, like I said earlier, the biggest question is, can it be separated physically? Um, if it is, it'll be a mixture and either be made up of a homogeneous mixture, it looks the same, heterogeneous, it looks different. Or if it can't be separated physically, you have to use a chemical reaction, that would be a pure substance. And if you have more than one element, it would be a compound. If you have just one type of element or atom, it would just be an element. Oh, that actually was not supposed to be there. So, after you are done this, check to make sure you have all your notes, and then you are going to do 1.1b, pure substances and mixtures practice problems. And that would be it for this video.